In this video, we will be walking through an algebraic example of completing the square using Al-Khwarizmi's method. The example we'll be working with is x squared plus 2x equals 8. The first step is to represent the equation. We'll start by creating a square such that the area is x squared. This would require that the side lengths of each side be x. The next step will be to add on a section whose area is 2x in total, and we do this by adding on 4 rectangles with the area of 1/4 of 2x. This way, when you add those rectangles back up, you get a total of 2x. We know that the long side of these rectangles are x, so in order to get the areas of 2x over 4, the other dimensions of the rectangles must be 2 over 4. If we wanted to make a complete square, we would need to fill in the 4 missing squares at the corners. And since each of its sides would be 2 over 4, the area of each of those new squares would be 2 over 4 times 2 over 4, which reduces down to 1/4. Now we know the area of the gray section is equal to 8 based on our equation. And if we wanted to find the area of the bigger square, that includes the pink areas, we would just need to add the area of the gray sections with the area of the pink sections. So 8 plus 4 sections of 1/4 each would be the same as 8 plus 1, which equals 9. The entire larger square's area is equal to 9. Therefore, each side of the larger square should be 3. Let's just focus on one side right now. If we know the entire side is 3 units in length, and we know what each section's length is, we can represent the situation in an equation that says 2 over 4 plus x plus 2 over 4 is equal to 3. We can now solve for the missing length of the middle gray section. Combining like terms, we get x plus 4 over 4 equals 3, and x plus 1 equals 3. When we subtract 1 from both sides, we'll get x equals 2. Let's compare this method to how we would solve completing the square today. When we complete the square, we want to search for a number we would add that would get us a perfect square when we factor the left-hand side. This happens to be the value of b, the 2, divided in half and then squared, almost like we're finding the dimensions of the pink squares for one side of the larger square, and then the area by squaring that number. To complete the square, we will add the new number to both sides of the equation, and on the left-hand side, we now have a quadratic that is a perfect square, and on the right-hand side, we have a total area of the bigger square, which is 9. If we factor this perfect square, we could then square root the 9, and in modern day math, we know that this results in 2 possible solutions, where x plus 1 is equal to 3, or x plus 1 is equal to negative 3. And solving for both, we could get that x is equal to either 2 or negative 4. Using Al-Khwarizmi's method, we were able to get to the positive solution of this equation.